Hi there, all attendees at O'Reilly's Etech 2009. I am Ian Martin Ajzenszmidt speaking to you through an electronic audio voice. This is really the text-to-speech software that is distributed under the name Verbose Text-to-Speech. Ever heard a male speaking with a female voice? With Verbose Text-to-Speech software this is possible. I live in a suburb of Melbourne, Australia, which is very distant from San Jose, the venue of O'Reilly's Etech 2009. Thanks to modern technology such as broadband internet, YouTube.com and Read Please, I can enable you to hear my speech, when you really can't, if you see what I mean. For various reasons, including the cost of airfare and accommodation, and medical reasons, I can't travel to San Jose, and present physically, so I am resorting to broadband internet and YouTube.com to present my speech to you. I would like to talk to you about automated, machine-based invention. That is, invention carried out by computer hardware and software. Please do not be skeptical. This technology is already in place, and inventing away. I am taking the liberty of reciting the contents of Robert Plotkin's blog automatinginvention.com. About automatinginvention.com. The Automating Invention blog explores the ways in which computers are automating the process of invention, and the legal implications of this phenomenon. Just as assembly lines automated manufacturing in the industrial age, computers today are using artificial creativity to automate inventing. Computer software is already responsible for designing the Oral-B cross-action registered toothbrush, an antenna that is headed into space on NASA's Space Technology 5 mission, and the turbine in Boeing's 777 airliner. Professor John Koza is documenting a growing number of instances in which computer software has designed a new patentable invention or duplicated an invention covered by an existing patent. There is even software that writes other software. Such artificial creativity software turns a computer into an invention engine, a machine for inventing other machines. The existence of such software raises difficult legal questions, such as, should a software-designed machine be protectable by patent law? If so, who is the inventor? Should the programmer of a particular artificial creativity program be entitled to patent protection for all of the inventions produced, or capable of being produced, by the program? If artificial creativity software eventually makes human inventors unnecessary, will patent law itself become unnecessary as well? The Automating Invention blog will explore these and other legal questions raised by computer-automated invention. Computers always have been used to facilitate the process of invention. While the first generation of computer software was only capable of transforming a general-purpose computer into a special-purpose computer and hence into a new machine, current artificial creativity software can design machines external to the computer on which it executes. Today's artificial creativity software, which is implemented using underlying technologies such as genetic algorithms and neural networks, is merely the latest, and certainly not the last, stage in the development of computers as invention engines. Although this blog will often use the term computer-automated invention, computers do not fully automate the process of invention. Rather, they automate some step in the inventive process and thereby free the computer's user from having to perform that step. As a result, the user is free to focus on other, more abstract, aspects of the inventive process. For example, the first generation of computer programming languages enabled programmers to manipulate a computer's circuitry to perform a new function merely by writing a program specifying the abstract procedure the computer was to perform, without the need to engage in the kind of physical circuit design performed by previous generations of electrical engineers. Similarly, current artificial creativity software enables people to create new software merely by specifying the abstract problem the software is to solve, without specifying a specific procedure for solving that problem. In other words, computers are enabling people to invent by engaging in ever more abstract kinds of design. The Automating Invention blog will explore the impact of computer-automated invention on human creativity and the kinds of skills that human programmers and engineers will need in the future. Computer-automated invention is making it possible to invent more quickly and less expensively than using human ingenuity alone. Furthermore, artificial creativity software is becoming increasingly capable of designing machines that could not be invented by human inventors in any reasonable amount of time. The Automating Invention blog will examine the consequences of this new kind of inventing for high-tech industry. As with every technological development, there is both promise and peril in the increasing power of computers to augment human inventiveness. The next generation of artificial creativity software may enable a school child to invent a cure for cancer or a weapon of mass destruction more quickly and using less skill and fewer resources than ever before possible. This raises questions for both individual ethics and public policy. Computer-automated invention has the potential to disrupt and perhaps eliminate entire professions or even industries, just as the assembly line and other forms of automated manufacturing did in the industrial age. The Automating Invention blog will examine these and other implications of computer-automated invention. The impact of the computer-automated invention revolution will be decided by our choices. Before we can choose, however, we must understand. The Automating Invention blog therefore seeks to promote widespread understanding of computer-automated invention and its implications primarily for the law, and secondarily for creativity, ethics, and high-tech industry. http://worldwideweb.automatinginvention.com/about.html http://snipperl.com/c20hb. This is the end of the excerpt from Robert Plotkin's blog, automatinginvention.com. 2003 book Genetic Programming 4th, Routine Human Competitive Machine Intelligence from Kluwer Academic Publishers, by John R. Koza, Martin Ajzenszmidt, Matthew J. Streeter, William Mydlowick, Ajzenszmidt, and Guido Lanza, ISBN 1-4020-74468. Kluwer Academic Publisher also publishes a DVD disc Genetic Programming 4th, video, Routine Human Competitive Machine Intelligence, by John R. Koza, Martin Ajzenszmidt, Matthew J. Streeter, William Mydlowick, Ajzenszmidt, Guido Lanza, and David Fletcher that is bound into this 2003 book. The four main points of the 2003 book are: genetic programming now routinely delivers high-return human competitive machine intelligence. Genetic programming is an automated invention machine. Genetic programming can automatically create a general solution to a problem in the form of a parameterized topology. Genetic programming has delivered a progression of qualitatively more substantial results in synchrony with 5 approximately order of magnitude increases in the expenditure of computer time. http://worldwideweb.genetic-programming.com/johnkoza.html number anchor 6,009,925. 9925. http://snipperl.com/c1zvh. Thank you for listening to this speech, and for your time.